Welcome to another explainer. As aquarium enthusiasts, we all know that sheer joy of a truly great tank. But today, we're looking at something that goes way beyond your standard glass box. We're breaking down the anatomy of custom aquarium design. So we're not just talking about keeping fish here. We are exploring the meticulous engineering and planning it takes to build a thriving, breathing ecosystem right inside a home or office. It's this incredible blend of biology, physics, and art. Now, what turns a standard fish tank into a living centerpiece? It's a great question. We usually just see that final dazzling look, right? The colorful corals, schooling fish, the perfect lighting, and it seems like that's the whole story. But honestly, the real heavy lifting happens long before a single drop of water even hits the tank. It's all hidden in those complex planning and design phases that guarantee water quality, structural safety, and long-term maintenance.
Now, what's really interesting about this slide is the approach. Generic, one-size-fits-all tanks are, well, exactly that. They're built for general use. But custom-tailored ecosystems, those are designed specifically to fit the exact dimensions of a room. They're built to support particular, sometimes super-sensitive species, and to meet very practical engineering needs. Basically, we're talking about tailored solutions over generic compromises.
Okay, let's dive into this chronological roadmap. First up, setting the initial vision. Then, biology and water chemistry. Third, engineering the build. Fourth, design specs and approval. And finally, commissioning the living system. This is basically our journey from an initial dream to a fully functional reality. So, step one, setting the initial vision, or defining the dream. Every successful project starts right here, with a crystal clear set of goals discussed openly between the designers and the client. This is where the creative intent really takes shape. First, you have to nail down the tank's purpose. Is it going to be a lively community display, a complex reef, or maybe a tank dedicated to just one specific species? Then you've got the aesthetics. Are you going for a minimalist look, a natural aquascape, or maybe dramatic open water viewing? And, absolutely crucial here, we have to look at the immediate physical boundaries of the room. I mean, how much wall space is actually available? Can the floor even handle that incredible weight? Where is all the equipment going to go? These aren't just aesthetic choices. If you get these physical constraints wrong on day one, it can literally derail the entire project. Which brings us to step two, biology and water chemistry. I love looking at this as building a living machine, because this is exactly where that creative intent we just talked about has to be translated into strict biological requirements. You have to remember, an aquarium is a closed environment, right? So it needs a highly precise life support system. Every unique ecosystem demands specific foundational constraints. You need temperature ranges explicitly tailored to the species you chose. You need exact lighting setups, especially if you're keeping plants or corals. Custom designs don't just use generic equipment, they prioritize a filtration system that's perfectly matched to the exact volume of the tank and the planned feeding schedules. Oh, and you absolutely must design precise water flow patterns. The last thing you want are dead spots or uneven conditions that could harm your livestock. And those biological requirements shift drastically depending on the water type. If you're building a marine reef setup, you are basically locked in a constant battle for absolute saltwater stability. You're going to need things like protein skimming and very careful nutrient control. But if you switch over to freshwater, the focus pivots entirely. There, it's all about maintaining stable water parameters and ensuring ecosystem compatibility among all the different species living together in that shared space. Once all that biology is mapped out, we hit phase three. Engineering the aquarium build. This is where we have to navigate real-world physics, making sure this custom aquarium performs safely and reliably under immense physical stress. Let's put this in a perspective. Water is shockingly heavy. We're talking roughly 8.5 pounds per gallon. So that immense weight means you absolutely have to reinforce floor loading and build incredibly strong structural stands. Then, you've got constant moisture exposure to deal with, which means carefully selecting suited materials and construction methods for the enclosures. And finally, operational logistics. Placement is everything. You have to plan your viewing angles, doorways, electrical access, and service clearances incredibly early in the process. Why? Because doing this now prevents some mind-bogglingly costly retrofits later down the line. And this brilliantly illustrates the core tension of custom builds. As the source notes, the most successful centerpiece designs hide complexity without making it hard to service, balancing aesthetics with real-world usability. Think about it. You have filtration, heaters, plumbing runs, lighting, controllers. It's a massive amount of tech. The ultimate goal is to integrate all those devices neatly into the final presentation so the viewer only sees the beauty while still letting the owner or maintenance team actually get in there and service the machine easily.
Now we move to step 4, design specs and approval. This is the formalization phase. All those biological constraints and engineering requirements, they finally get put onto paper for the client to review and approve. Let's move to the blueprints and see how this all builds out. First up is visual planning. That's locking in the dimensions, the silhouette, your hardscape layout, and the lighting style. Next, we hit the highly technical specification stage. This involves selecting exact equipment models, running flow calculations, and drawing out complex plumbing schematics. Finally, the client review. This is where clients actually sit down with the mock-ups to confirm sightlines, proportions, and figure out exactly where vital things like built-in filtration chambers and maintenance access panels are going to sit. It's also at this approval stage that the budget and timing get fully clarified. And let me tell you, these can vary wildly. If you start adding tank curves, totally unusual dimensions, rimless glass, custom sumps, or specialized cabinetry, all of that will directly drive up the final budget and timeline of the build. It really just comes down to the level of complexity you want to integrate. All right, we have finally reached the final phase, commissioning the living system. The fabrication is done, and now we begin the incredibly important transition from a designed object to a fully operational living environment. This final setup process is absolutely crucial. You always start with proper leak testing and equipment calibration, just to ensure physical integrity. Nobody wants a flood in their living room, right? Once that's secure, you move into biological cycling. Now, this is mandatory. You have to establish stable water quality before any life is added. Only after that cycling period does the aquascaping and livestock introduction begin. And finally, the fine-tuning, carefully adjusting flow patterns and lighting schedules based on exactly how the new environment is responding. So the crucial point here is that custom aquarium design is ultimately a multidisciplinary workflow. It blends biology, engineering, aesthetics, and operational planning all into a single cohesive build. By addressing these factors early and treating the centerpiece as a true working system, you guarantee a tank that doesn't just look visually stunning, but actually functions well and supports the long-term health of the life inside. Which leaves us with this final thought. Now that you understand the incredible mechanics behind these living machines, if you were building your own custom centerpiece, what kind of ecosystem would you design? Would you go for a vibrant, incredibly complex reef, or maybe a peaceful, freshwater natural aquascape? The possibilities are honestly endless once you understand the engineering behind the art. Thanks for joining me on this explainer, and keep learning.